Hello. How is everybody today? Good. Watch for Hunter to log in. Hunter, you're already there, not Hunter. Meant to say Noah. Real quick before we get started, does anybody have any questions on anything that we've gone over previously? Anything with scientific notation? Anything with, excuse me, with our fraction wrap up, ratios, proportions, scale drawings? Everybody good so far? All right, well, hopefully Noah will log in shortly, but we'll go ahead and get started. I'm gonna go ahead and share my screen. So today we are gonna start on a new unit dealing with percents, okay? So this is gonna be with lesson 47. So you can go ahead and open your book to lesson 47. I'm gonna go ahead and get my pages pulled up. Okay. So starting with lesson 47, dealing with percents. So it says percent means hundredth. Notice that it has the TH on the end of it, or per hundred. Okay, so percent means hundredth or per hundred. It is used to show how one quantity compares in size to another quantity. For example, if you receive a 90% on your test, you have correctly answered the equivalent of 90 out of 100 questions. It does not mean that there were 100 questions on the test, but the ratio of questions you answered correctly was an equivalent of 90 to 100. So remember, just recently we talked about ratios, how a ratio compares one thing to another. A lot of times it's expressed as a fraction. So we have that numerator and denominator. So that's what it's talking about here, that if we looked at an equivalent fraction for numbers that you got correct on a test, then that's what it would look like. To express a to express a percent as a decimal, divide by 100. If you have 100% of something, you have one whole of that thing. If you have 200% of something, you have two wholes of that thing. If you have 50% of something, then you have the equivalent of 0.5 or half. Okay, so we're going to be looking at things that, you know, we're judging based on percent. 100% means one whole of something. So that means anything under 100% means it is less than the whole item. Anything over 100% means you have something greater than one whole item. So it says, conversely, to express a decimal as a percent, multiply by 100. So we're going to look at converting percents to decimals and decimals to percent today. Okay. So notice it says to express a percent as a decimal, divide by 100. And then to express a decimal as a percent, you multiply by 100. Now remember, if I'm going percent to decimal, I'm going to drop my percent sign. If I'm going from decimal to percent, I have to add a percent sign. All right, so this says to convert each percent to a decimal, okay, is what we're looking at first. So what I want to do is I want to go ahead and make a note here. So we said to go percent by decimal, you need to, well, stretch my screen. There we go. Divide by 100. Okay, so I've just written a note over here to help me remember based on what they told me in my guidelines. So that means here, I'm going to write this as 8 divided by 100. Okay. And so that means I'm putting 100 into 8. Well, obviously that doesn't work. So when I divide a number by a number that is larger than it, I put my decimal and I add a 0. Well, even adding 1 0 isn't going to get me there, but adding 2 zeros. Okay. So I'm going to go ahead and put my decimal in my answer. And 100 will not go into 80, but it will go into 800. So 8 times 100 is 800, and I subtract. Okay, so I've ended up with decimal 08. Okay, so one of the things I want you to see by using that method, if I have 8%, this is going to be the same as if right now my decimal is right there after the 8, and actually I'll make it a different color. In 8%, my decimal is right after the 8. So dividing by 100 is going to be the same as moving my decimal 2 places to the left. Okay, so I want you to go ahead and make a note right underneath to express a percent as a decimal. Put dividing by 100 is the same as moving the decimal 2 places to the left. Okay, so if I remember that dividing by 100 is the same as moving my decimal 2 places to the left, when I look at working that problem, that's a whole lot easier than having to do 8 over 100 is 100 divided into 8, and then I have to put my decimal and my zeros and divide and all that stuff. Okay, so it's going to be a whole lot easier. Now what I'm going to do is I'm just going to erase all this. And I'm going to show that if I had 8, I move my decimal 2 places to the left, fill with a 0, and drop my percent sign. So 0.8. Okay, move the decimal 2 places to the left and drop my percent sign. So let's look at 25%. Right now my decimal is after that 25. So I'm going to move my decimal 2 places to the left and drop my percent sign. So that would be decimal 25. 33%. My decimal is after the 33. I move my decimal to the left 2 places and drop my percent sign, so 0.33. Go ahead and do the next 3 on your own. Your decimal is going to be after your last digit. If it's not already placed there for you, you understand that it's going to come after your last digit. So you just move it 2 places to the left and drop the percent sign. And once you finish, you can look up and check yours. So 80% is equal to decimal 8. 150% is equal to 1.5. 275% is equal to 2.75. So remember, anything over 100% means I have more than one whole. So in this situation with 150%, I have a whole of something and half of another. With 275%, I have 2 of an item and 0.75 of another item, or 3/4 of another item. So I almost have 3 total of that, okay? All right, so now we need to go from decimal to percent, okay? So decimal to percent means I'm going to multiply by 100. And so what I'm going to do up here is where it said divide by 100, I'm going to put in parentheses, move decimal 2 places to left and drop percent sign. So now with multiplying by 100, that means I'm going to move decimal 2 places to the right and add my percent sign, okay? So I start out with 0.1. I start where my decimal is, and multiplying by 100 is the same as moving my decimal 2 places to the right. So I would go 1, 2. That's where my decimal needs to move to. I backfill with a 0. So that gives me 10, and then I add my percent sign. So 10%. With 0.67, I start where my decimal is, move it 2 places to the right, and add my percent sign. Now notice when I'm writing a percent, I'm not going to actually write my decimal in it unless, and I'll show you an exception in just a minute. For 0.99, 2 decimal places to the right, add a percent. 1.4, 2 places to the right, I need to add a 0, 140%. 2.66, 2 places to the right, add percent sign. Now notice my 3. My understood decimal is after my 3, so I need to move it 2 places to the right. I would backfill with 0, so that will be 300%. Like I said, in none of these did I write my decimal. I didn't have to. Now I could have put a decimal after the 10, a decimal after the 67, but I don't have to. What I would have to do is, let's say I had a number like this, 1.465. If I needed to change that to a percent, I would have to move my decimal 2 places, and notice it would now move to between the 6 and a 5. So in that situation, I would have 146.5%. Okay, so if when I move my decimal 2 places, if I still have a number after that decimal moves 2 places, then I have to make sure I've got my decimal in my answer. But if it doesn't, sorry about the phone ringing, but if it doesn't have a number after where the decimal needs to go, then I don't have to have it. So like 300%, I don't have to have a decimal after that last 0. The only time I would have to have another decimal in my percent answer is if when I moved it 2 places, there's still a digit. Everybody good with that? All right, so now what we're going to do is we are going to look at converting each percent to a decimal and each decimal to a percent. All right, percent to decimal. That means I'm going to move my decimal 2 places to the left and drop my percent sign. So it starts after my 4, 2 places to the left. So that's going to be 0.14. Now, the other thing to mention is that if you would like to put a 0 in front of your decimal, that is fine too. It does not change the value. So you can either have a 0 and then a decimal, or just have a decimal. It's the same thing. It's up to you. Okay, so 30%, your decimal is after the 0, 2 places to the left. So 0.3. Now again, I can have 0.3 or I can have 0.30. which is the same as 0.3 or 0.30. My zeros, when I'm dealing with my decimals, it doesn't matter if I have one in front of the number. It doesn't matter if I put another one after the number. The value is still the same. Okay? So on that one, if you wanted to have 0.30, you could. 0.3 is the same thing. All of these mean exactly the same thing. 0.3 is the same as 0.30. 0.3 is the same as 0.30. All right, 45. My decimal is after the 5. I move it 2 places to the left. So I have 0.45. 70%, my decimal is after the 0, 2 places to the left. So 0.7 or 0.70, either way. 125, my understood decimal is after the 5. I move it 2 places to the left. So it's going to be between the 1 and the 2, 1.25. Same thing with 180%. My understood decimal is after the 0. I move it 2 places to the left. So I have 1.8. Again, I could have 1.80 or just 1.8. Now, when I have 3%, my understood decimal is after the 3. I have to move it 2 places to the left. So that means I've got to backfill with a 0. So I have decimal 0.3. Now, decimal 3 and decimal 0.3 are 2 totally different numbers. So I've got to make sure that if I move my decimal 2 places to the left and there's not a digit, that I do backfill with zeros. And then 10%, my decimal is after 0, 2 places to the left, 0.1 or 0.10. 85 or 85%, move my decimal 2 places to the left, and I have 0.85. Any questions on those? All righty, so what we will do is we will have this right-hand column for homework, and today is 11/9. So now we will do the left-hand column of activities 3. Decimals to percents. Decimal moves 2 places to the right, add the percent sign. I have to start where the decimal is in my original number. So I have 0.49. I'm going to start where my decimal is and move it 2 places to the right and add a percent sign. 0.97, 2 places to the right, add a percent sign. 0.26, 2 places to the right, add a percent sign. Now 3.4, 2 places to the right, I have to backfill with a 0, so I have 340%. 6.71, 2 places to the right, 671, add a percent sign. With 8, I understand my decimal is after the 8, so I've got to move it 2 places to the right. That means I backfill with zeros, so I have 800%. 0.2, 1, 2 places, fill with a 0, add my percent. 0.07, 1, 2 places to the right, so I have 7%. And 1.01, 2 places to the right, is 101%. Now let's go ahead and take a look over here just a minute at this one right here. Okay, I have decimal 0.0036. We're going to do this one together. I start where my decimal is, go 2 places to the right. Okay, so that means I'm going to have decimal 0.36 and then add my percent sign. Okay, I can only move my decimal 2 places to the right, but because there are still digits after the decimal when I move it, I have to have a decimal and my percent sign. Okay, so it would be 0.036%. Now the rest of this will be for homework 11/9. So you may look back at your instructions percent to decimal. Decimal goes to the left 2 places, drop your percent sign. Decimal to percent, 2 places to the right, add a percent sign. Any questions about that? All right, let's go ahead and take a look. Least common multiple of a set of numbers, okay? This is reviewing way back from the beginning, so but let's go ahead and look at that. Least common multiple, remember that was our LCM. And we looked at those and we said, hey, what number is a multiple of 6, a multiple of 10, and a multiple of 12? What is the same multiple, but it's the smallest one they have in common? We said we could do it one of several ways. I could list all my multiples of 6, 6 times 1, 6 times 2, 6 times 3, 6 times 4, and go on that way. And then I have to list my multiples of 10 and my multiples of 12. Or I can do prime factorization and then multiply all of my common multiples together. Or actually I have to multiply all my highest exponent of all multiples together. So let's review that for just a minute. So I'm going to look at the number 6, and that's 2 times 3. Remember, prime factorization, my smallest prime number is 2. Okay, and when I'm dealing with prime factors, I'm looking for multiples, or I'm looking for factors of a number that are prime factors. Remember, prime factors only have factors of 1 in itself. Okay, so we said that one is 6 is 2 and 3. 10 is 2 times 5. And then 12, we have 2 times 2 times 3. So we can represent that as an exponent, 2 squared times 3. Now remember, in this situation, I've got to look and see what is the largest exponential value for every factor. So I see that I have a 2, a 3, and a 5. I know that I've got to take my largest exponential for each of those factors. So my highest is going to be 2 squared. I have 3's in a couple of them, so I'm just going to go ahead and represent that 3 and the 5. Okay? So I'm going to have 2 squared times 3 times 5. 2 squared is 4, so I have 4 times 3 times 5. 4 times 3 is 12, times 5 is 60. So my least common multiple is 60. Now, another way I could have done that is, like I said, if I had 6 and I had 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. I'm having to do a whole lot more than I'm doing when I'm doing my prime factorization, because then I've got to do it for 10, 20, 30, 40, 50, 60, then 12, 24, 36, 48, 60, but then I can see that I've got those in common, okay? So either way, I can either list them out, or I can use my prime factorization, but then I multiply the highest exponent for each factor represented. So I cannot leave one out. I have to do the highest exponent. So let's look at 10, 15, and 20. 10 is 2 times 5. 15 is 3 times 5. 20 is 2 times 2 times 5. So I would represent that as 2 squared times 5. Again, I have 2, 3, and 5 as my factors being represented. My highest exponent of 2 is 2 squared. I have a 3 and I have a 5. So I would multiply those together. 2 squared times 3 times 5. 2 squared is 4. 4 times 3 times 5. 4 times 3 is 12. 12 times 5, again, is 60. And then the last one, 9, 12, and 15. 9 is 3 times 3, so I would write that as 3 squared. 12 is 2 times 2 times 3, so that would be 2 squared times 3. 15 is 3 times 5. I still have 2's, 3's, and 5's, but I have to take the highest exponent of each value. So that would be 2 squared 3 squared, and 5. So 2 squared times 3 squared times 5. 2 squared is 4. 3 squared is 9. Then we have 5. So on this one, 4 times 9 is going to give me 36. And then 36 times 5, I'm going to have 36 times 5 is 180. Now, looking at that one, I sure wouldn't want to have to list out all of my multiples of 9 until I get to 180. That's why using the prime factorization and understanding this method is going to be the easiest and the quickest, because I don't want to have to list out my multiples of 9, 12, and 15 until I get to one in common, and it's not until 180. All right, so quick review on least common multiple. Let's look at fractions to decimals, okay? Remember that when I have a fraction, that is also a division problem. I'm dividing my numerator by the denominator. So this is the same as 3 divided by 4. So if I ever don't know a fraction, if I haven't memorized the fraction to decimal conversion, if I don't know automatically that 3/4 is equal to 0.75, then I could always work it out as a division problem and do 4 divided into 3. But hopefully you know that that's 0.75. 3/4. So I always think about, especially the easiest are going to be 1/4, 2/4, which is 1/2, and then 3/4. Those should be the first ones that you end up memorizing. But like I said, if you don't have them memorized, and let's say you don't know what 2/5 is, remember this is the same as 2 divided by 5. So that means I'm going to put 5 into 2. 5 won't go into 2, so I have to add that decimal. 5 will go into 24 times. So then I can see that that would be the same as decimal 4. Okay. Same thing with 1/6. If you did not have it memorized, you could do 6 into 1. It won't go, so I have to go ahead and put my decimal. And 6 will go into 10 one time. 1 times 6 is 6. I subtract and I've got a 4. I add a 0 and bring it down. 6 will go into 40. 6 times 6 is 36. I subtract and I've got a 4. I'm starting to see a pattern here, okay? So again, I can see that my repeating digit is only going to be the 6. So when I write this as a decimal, I'm going to have decimal 1/6, but I'm only going to write my repeating digit over the number that repeats, and that is the 6. The 1 is not repeating, just the 6. Okay. 5/8. 8 won't go into 5, so I add my decimal. 8 will go into 50. 6 times 8 is 48. Subtract. 50 minus 48 is 2. Add another 0. Bring it down. 8 will go into 20 2 times. 2 times 8 is 16. Subtract. That's going to give me 4. Add another 0. Bring it down. So when I'm working on these, I want to keep dividing until till it terminates or till it repeats. Now I can see that 8 will go into 40 5 times. I'm done. And so this is going to be 0.625. And then 3/10 is going to be the same as 0.3. And that's where we look at our tenths place. Yours where your 3 is. But again, you could divide it out if you needed to. Okay. So the rest of this side over here will be homework. 11, 9. So activities 5. The right-hand column, you're going to write the decimals in fraction form. Now remember, you do have that table that we looked at in the textbook several sections back. If you need to flip back if you can't figure it out. All righty, activity 6 is reviewing our proportions. So what I want to do is I want to review what a proportion is. Remember, a proportion is 2 equivalent ratios. And we learned, so I'm going to go ahead and put this definition right over here. 2 equivalent, Q-U-I-V-A-L-E-N-T, ratios. And remember we said ratios is the same thing as a fraction. Okay, a ratio is the same thing as a fraction. I'm comparing two pieces of information. I'm comparing something to something else. And so when I have a proportion, that's the same as equivalent fractions. Okay, so proportions and equivalent fractions are going to be the same. And so remember, we talked about how to solve for an unknown piece of information in a proportion. I can cross multiply. So in this situation, I would say, okay, if x over 12 equals 15 over 40, I multiply the numerator of the first equation by the denominator of the second. So that's x times 40 would be 40x equals 12 times 15. Okay, so hang on a second. Noah's mom can't find the link. Let's see. Let me pull this up for her real quick. Meetings. PreAlgebra Monday. Okay, hopefully he'll join in just a sec. Okay, so we multiply and we've got 12 times 15. And 12 times 15 is 180. So we have 40x is equal to 180. Remember, when I'm solving for a variable, I look to see what operation is going on so I can undo it. So I have 40 times x, so the opposite of that would be division. So I would divide by 40 because I want x to be by himself. So x is equal to, and 180 divided by 40. Again, in this situation, I can divide 40 into 180. 40 will go into 180 4 times. 4 times 4 is 16. So I've got 160. 180 minus 160 is going to be 20. Now, remember, to be able to put a decimal and bring a number, to be able to keep going, I've got to add a decimal and a 0, and then I can bring my 0 down. So now I have 200. So 40 will go into 200. I put my decimal in my answer. It'll go 5 times, and 5 times 40 is 200. So x is equal to 4.5. Okay, cross multiply, set up an equation where you have multiplied numerator by denominator, numerator by denominator, and then solve for x.
Wait, it says leave answers in improper fractions.
Oh, okay, cool. So what? Let me fix that then.
So that would be 9 over 2, right?
Yeah, so basically we would have 180 over 40. And remember, this is going to be where I look to see how can I reduce. I want to I always want it to be in simplest form. Remember, if you can't figure out the best number to divide by, you can always start. They're both even, so I can divide by 2. So half of 180 is 90, half of 40 is 20. Now I can see that I can divide by 10 here, divide by 10, divide by 10. And I can see that I would have 9 over 2. Okay, so either way that you want to be able to simplify, you just want to make sure you've got it in simplest form.
I reduced the top fraction because 15 became 3 and 40 became 8.
Okay.
Which made it a lot easier.
Yeah. The bigger number you divide by, the less work you have to do. Yeah, if you get the bigger number right off the bat, then it's going to be easier. Hey there, Noah. Sorry you're having trouble. What we'll do is during the break, in just a little bit, I will catch you up on what we did. Basically, what we've started is about percents. And we said percent means per 100, or use the 100th, meaning after the decimal, it's the second place after the decimal point in a number. And we worked on converting percents to decimals and decimals to percents. And so I'll catch you up on this at the break, and then I can send you my pictures of my notes for you to have as well. All righty. So we have reviewed on least common multiple. We've reviewed on fractions to decimals. And now what I'm going to have you do is, for homework, you will do these last 3 proportion problems. So homework 11, 9. And I'll go ahead and highlight them so y'all can see. Well, let me make my pen brighter. Okay, we're doing those 3. So here we have homework here, and here. Any questions about any of that? Real quick, we'll review. Percent to a decimal, divide by 100, means you're moving your decimal 2 places to the left and you drop your percent sign. Decimal to a percent, you are multiplying by 100, which means you move your decimal 2 places to the right and add the percent sign. So that's what you're doing in that section of homework. In activities 5, you are writing the fraction equivalent of the decimal, and then you have 3 proportions to solve by cross multiplying. And then I did too much here. We didn't have to divide. We just left it as an improper fraction. Any questions about any of that? All righty. We will keep on going. The next section is finding the percent of a number. Okay, so finding the percent of a number. It says to solve percent problems, follow these steps. Let me make my... Okay, so it says step 1 will be to change the percent to a decimal if one is given. So the first thing we do is change the percent to a decimal if it's there. Okay. Step 2 is to set up an equation using a variable to represent the unknown. So set up an equation, use the variable to represent the unknown. Step 3 is to solve for the variable. And step 4 is going to be to change the decimal to a percent if you're asked to find a percent. Okay, so we've got to look and see if I have a percent to begin with, I've got to change it to a decimal. Then I set up an equation and I use a variable. Usually the most common is going to be the variable x. So I can plug in the variable x for whatever I don't know. Then after I've solved, if I'm trying to solve for a percent, I need to convert my answer, my decimal answer, to a percent. So the example they gave us is, what is 25% of 50? Now what I want to do is I want to show you there is just a standard equation, and I can use percent times whole equals part. Okay, so if I multiply a percent times a whole number, that equals the part I'm looking for. So in this situation, I have percent of 50. Of in math means times. Okay, so that means I've got 25% times 50 equals X, because I'm trying to find my part. Remember, step one was to change my percent to a decimal. So 25% is going to be 0.25 multiplied by 50 equals X. Then when I multiply 0.25 times 50, that is 12.5 equals X. So that is my part. So in this equation, I plug in 25% times 50 equals X. Percent times whole equals part. So if you remember that formula, it doesn't matter what two pieces of information you're given, you can plug it in using that same formula and solve for the unknown. So let's look at the examples they've given us of what is 15% of 60. Remember, that means I would have 15% times 60 equals X. I'm using multiplication because of the word of, and I'm letting my variable X represent what I'm trying to solve for. Step one said I have to change my percent to a decimal, and we've worked on changing percents to decimals. This means I move my decimal 2 places to the left and drop my percent sign. So 0.15 times 60 equals X. I'm going to multiply 0.15 times 60. So remember, this will be the same as 60 times 0.15. 0 times 5 is 0. 6 times 5 is 30. 0 times 1 is 0. And 6 times 1 is 6. Add them up. 0, 0, 9. Now I look at how many decimals I have in my original problem, and there's 2. So I start at the end and go over 1, 2 places. So X is equal to 9. Okay. Let's look at the next one. 30 is 40% of what number? In math, is means equals and of means times. Okay, so if I know percent times whole equals part, I can use that same formula. So percent is 40% of what number? I do not know, equals, well, not 13, 30. I'm using my same formula of percent times whole equals part. I'm plugging in the information that the problem gives me. It tells me 40% of, when it says what number, that's where I know I'm using my variable X to represent the unknown. Is my equal sign and 30. Okay, so now again, change my percent to a decimal. 40% is the same as point. We could have 0.40 or just 0.4. So we have 0.4 times X is equal to 30. Remember, if I have 0.4 times X, to undo it, I'm going to have to divide. So that means I divide by 0.4, divide by 0.4. Now, I've got to be careful when I'm dividing with decimals. So that means I've got 0.4 into 30. Now, when I have a decimal number outside of my division sign, remember, I cannot divide with that decimal there. I have to move my decimal 1 place to the right and make that a whole number. But because of the properties of equality, I cannot do one thing to one. I can't do something to one that I don't do to the other. So this number started out as 30. I have to add a decimal and move it to the right as well. So now my number is 300. My number on the outside is now 4. My number on the inside is 300. So 4 will not go into 3, but 4 will go into 30 7 times. Notice I put my 7 above the 0 because I used 30. 7 times 4 is 28. 30 minus 28 is 2. Bring down my 0, and 4 will go into 20 5 times, and 5 times 4 is 20. So now I find that my answer is 75. So x is equal to 75. So 40% of 75 is 30. Okay, so now I can plug it all back in and say 40% of 75 is 30. Let's look at the next one. 40 is what percent of 125? If my formula is percent times whole equals part, I'm going to plug in what I know. I know I've got my equal sign there, and I can see over here it equals 40. My x, my variable, will represent my percent because I don't know what it is. I do know what my whole number is. So I have x times 125 equals 140. So that's going to be 125x equals 40. Now again, 125x means I'm multiplying. So to undo that, I have to divide by 125, divide by 125. So x equals, now I've got 125 into 40. It will not go into 40, so I'm going to have to add a decimal and a 0. So 125 will go into 40 3 times. 3 times 5 is 15. Carry my 1. 3 times 2 is 6, plus 1 is 7. And 3 times 1 is 3. So I've got 375. 400 minus 375 is 25. Add a 0, bring it down. And 125 will go into 250 2 times. 2 times 5 is 10. Carry my 1. 2 times 2 is 4, plus 1 is 5, and 2 times 1 is 2. So now I can see my answer is 0.32. Now remember, in this question, it says what percent. So now I have to change my decimal to a percent. To change a decimal to a percent, I move my decimal 2 places to the right and add a percent sign. So x equals 32%. Okay, it is break time. So we'll go ahead and take our break, and then we will come back and keep practicing with these. And let's see, Noah, what I'm going to do is I didn't mean to do that. I will. I'm going to screenshot pictures of these to send to you. And then you were here for that. So let's see. All righty, we'll go ahead and come on back. Work through some more of these examples. And what we'll do is we're going to do an example of each of them. So I'll go ahead and highlight the ones that we're going to do. We'll do 30% of 90. 25 is 40% of what number, and 30 is what percent of 150. Actually, we might go ahead and do a couple of each. We'll do 9 is what percent?
We lost Olivia.
I'm still here.
Oh, you're still here?
Yeah.
Okay. All right, so 9 is what percent? Let's do.
We lost Avery there.
Yep. We'll watch for her to come back. Okay, so what we'll do is the highlighted ones that I've done, we'll do these three together. Here she comes. Okay, so we'll do the highlighted ones together, and then the rest of them will be for homework. So the first thing we're going to start with is what is 30% of 90. If you want to go ahead and write at your activities, remember we're doing percent times whole equals part. Now, if it helps you, if you want to condense that, you could just do the percent time, or percent time, the percent sign times W equals part. That's just a shortened way to remember it. So then that way, if you wanted to write that before you plug everything in, you could have percent times W equals part. Then look to see what two pieces of information you have and plug them in those locations. So I have 30% times, that's where I have of, that means times. Remember is equals. So if it says what is, I know I'm looking for X. I know I've got my percent and my whole number. So first step, I need to change 30% to a decimal. So that will be 0.3. I could have 0.30 if I wanted to. It's the same thing. So 0.3 times 90 equals X. So I know that 9 times 3 is 27. So 3 times 90 would be 270. I've got a decimal in there, so it will be 27 equals X, or X equals 27. So 27 is 30% of 90. Let's move on down here to the next one that I've got highlighted. 25 is 40% of what number? So percent times whole equals part. I have a percent of what number tells me that I do not have my whole number. So I'm going to let X be that variable, and that's going to equal 25. First step is to convert my percent to a decimal. So 0.4 times X is going to be 0.4X equals 25. 0.4 and X are being multiplied, so I need to divide by 0.4, divide by 0.4. So I've got 0.4 into 25, move my decimal one time, move my decimal one time here. So now I'm dividing 4 into 250. 4 will go into 25 5 times. 5 times 4 is 20. I've got a, that's not right. 6 times 4 is 24. Subtract 5 minus 4 is 1. Bring down my 0. 4 will go into 10 2 times. 2 times 4 is 8. Subtract, I've got a 2, add a 0, bring it down. 4 will go into 20 5 times. So X is equal to 62.5. Now be real careful and make sure, like in this number, it's saying what number. I'm not solving for a percent, so I'm not having to change 62.5 to a percent. Okay, always be careful and pay close attention to what type of number. The only time you're going to change an answer to a percent is like the next one where it says what percent. Okay, so 30 is what percent of 150? Percent times whole equals part. I do not know my percent, so that is my variable. I'm going to put X in, times whole. Remember, it's going to be whatever follows the word of is going to be my whole number. So X times 150 equals 30. So that's 150X equals 30. Divide by 150, divide by 150. So I'm going to have 150 into 30. That won't go, so I need to add a decimal and a 0. Put my decimal up in my answer. 150 will go into 300 2 times. And 300 minus 300 is 0. So X is equal to 0.2. Now this is where I have to pay attention because it says I'm looking for a percent. I've got to change from a decimal to a percent. So that means I've got to move my decimal 2 places to the right and add a percent sign. So X is equal to 20%. Any questions on any of those? I highly, highly, highly recommend you starting with this generic equation. So that way you've already got it written out. You know where to plug in the information you're given. You may know a percent, you may know a whole number, you may know a part, but the main thing is plugging them into the correct location to be able to solve for the unknown. Okay, we'll do a few more. What is 220% of 80? Actually, I want you to go ahead and work on this one on your own. What is 220% of 80? I'll give you a minute to work on it, and then we're going to look at it together. No. All righty. So in this one, you should have had your percent times whole equals part. We know 220% is our percent. We know that 80 is our whole, and we're trying to solve for our part. So with 220%, we need to convert this to a decimal first. Remember, we move our decimal 2 places to the left after we've dropped our percent sign. So that is going to be 2 decimal 2. Move it 2 places to the left. So 2.2 times 80 equals X. So now I'm going to multiply 2.2 times 80. Put my 0 there. 2 times 8 is 16. Carry my 1. 2 times 8 is 16 plus 1 is 17. I have 1 decimal place. So I know that 176 equals X, or X equals 176. How'd everybody do on that? Any questions? Any problems? All right, go ahead and work the next one. 30 is 120% of what number? Percent times whole equals part. Plug in what you know. Use a variable to represent what you don't know. All right, so in this one, percent times whole equals part. We have 120%. We don't know of what. We don't know our whole number, but we know that it is or equals 30. So 120% times X equals 30. I need to change 120% to a decimal first. My decimal is at the end of 120, so I move it 2 places to the left and drop my percent sign. So it is 1.2 X equals 30. 1 decimal 2X equals 30. I am multiplying 1.2 and X, so to undo it, I need to divide by 1.2. Now to divide 1.2 into 30. Remember, my rules of division was decimals. I cannot divide by a decimal. I have to convert it to a whole number. To change 1.2 to a whole number, I need to move my decimal 1 place to the right. If I do that to that number on the outside, I have to do it to the number on the inside. So it was 30, so now I converted it to 300. So now I have 12 into 300. 12 will go into 30 2 times. 2 times 12 is 24. 30 minus 24 is 6. bring down my 0, and 12 will go into 60 5 times, and 5 times 12 is 60. So x is equal to 25. How'd you do? Did you do okay? Plug them into the formula. All right, last one. 9 is what percent of 180? Don't forget to change your answer to a percent. All righty, so on this, percent times whole equals part. In our question, it says what percent? So we know that that's going to be x. My percent will be x. Of 180, we know 180 is the whole, is 9, equals 9. So that means I have 180 times x equals 9. Because 180 is being multiplied by x, I need to divide by 180 to solve for x. So now I have 9 divided by 180. So 180 goes on the outside into 9. Obviously, 180 will not go into 9. So I add a decimal and a 0. 180 will not even go into 90, so I need to add another 0. I do not want to forget my decimal up top. So 180 will go into 90 0 times. 90 minus 0 is 90. Bring down my other 0. So now 180 will go into 900. How many times? So that's going to be 5. 5 times 0 is 0. 5 times 8 is 40. Put down my 4, put down my 0, carry my 4. 5 times 1 is 5, plus 4 is 9. So we found that x is equal to 0.05. My question asked me what percent. So now I know I need to change 0.05 to a percent by moving my decimal 2 places to the right and adding a percent sign. So x equals 5%. Questions? Awesome. Okay, so for homework, we will have, what I'll do is the homework ones I'll highlight in pink here. So we'll have the top two, second row two, and then on the bottom, we've got two in the middle. So if we want to number these, we could say we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means we have 2, 3, 4, 5, 8, and 11. Okay, so numbers 2 through 5, 8, and 11. Homework on 11, 9. All righty. Let's go ahead and look at our next page. And let's review some of this on page 106. It says, find the prime factorization of each argument and simplify the roots. So let's shift gears for a moment and think about prime factors. We have square roots here. So remember that when I am dealing with square roots, I always want to try to simplify as much as possible. The way I do that is by listing the prime factors of a number, looking at the buddies, and then pulling out whatever whole numbers I can. If I don't have numbers that are buddied up, they have to stay under the radical in my final answer. So let's look at the square root of 96, and I'm going to start with prime factors. Remember that I always want to start with my smallest prime factor of 2. If it's an even number, I know it's divisible by 2. So 96, I'm going to start with 96 divided by 2. Excuse me. So I'm looking at what is half of 96. Half of 96 is 48. Okay, so now I'm thinking about the number 48 and I want to break it down. My smallest prime factor of 48 is also 2. Half of 48 is 24. Now I'm breaking down 24. Smallest prime factor is 2, and that's 2 times 12. Smallest prime factor of 12 is 2, and that's 2 times 6. Smallest prime factor of 6 is 2, and that's 2 times 3. So now I have all prime factors listed out for the square root of 96. I could check it by multiplying and saying 3 times 2 is 6, 6 times 2 is 12. 12 times 2 is 24, 24 times 2 is 48, and 48 times 2 is 96. Okay, so I can always check and make sure that I didn't write too many of a number and that I got enough. Okay, now remember we talked about how with a square root, my understood index, that little bitty number above my radical, is the number 2 to indicate square root. Even if it's not there, I need to understand that it's there. And so that means I need 2 of each prime factor to come out from under the radical as a whole number. So now these are what we call my buddies. So I've got some buddies right here. So that means that 2 is able to come out. I've got these buddies right here. So another 2 comes out, and I've got to multiply those whole numbers together. Now, under the radical, I still have a 2 and a 3. They cannot be buddied up, so they have to stay under the radical. Okay, so I was able to pull 2 2s out, but the 2 and the 3 had to stay, so I'm going to simplify that. 2 times 2 is 4, under the times the square root of 2 times 3 is 6. Find your prime factors, buddy them up, pull out whatever whole numbers can come out. Whole numbers are multiplied together. Radicals that are left underneath the radical sign are multiplied together for your final answer. So let's look at the square root of 72. Again, I'm going to start with my smallest prime factor, which is 2. And half of 72 is 36. and then so 32, blah, I'm getting all my numbers run together. Half of 72 is 36. 36 divided by 2 is 18. 18 divided by 2 is 9. And so 9 is not even, so I can't divide by 2, but that will be 3 times 3. So I've got 3 times 3 is 9. 9 times 2 is 18. 18 times 2 is 36. And 36 times 2 is 72. I look at my buddies. My understood index is 2. So I have 2 2s and 2 3s. Those are able to come out as whole numbers. We'll need to multiply them together. I only have a 2 left under my radical. So 2 times 3 is 6 times the square root of 2. Any questions on that? Let's look at the next one. 3 times the square root of 75. I already have a whole number, so it's going to stay there. So 3 times the square root of. I'm going to start by taking my smallest prime factor. If it is not an even number, then I want to try the number 3. Remember, I can check divisibility of 3 by adding my digits together. And 7 plus 5 is 12. 12 is divisible by 3. So that one's going to work. So I know that if I divide 75 by 3, that gives me 25. And I know my factors of 25 are 5 times 5. So those are my buddies right there, 5s. My 5 comes out, but I already had a 3. So now I have to multiply the 5 that I'm pulling out. I cannot forget that whole number of 3 that I started out with. So I've got 3 times 5 on the outside. Under my radical, I'm left with a 3. So 3 times 5 is 15 times the square root of 3. All right, 216 is even, so I'm going to divide it by 2. That would be 108. That's even, so I'm going to divide by 2. That would be 54, which is even. Divided by 2 is 27. Now, 27 is not even, so it's not divisible by 2, but it is divisible by 3, and that's 3 times 9, and 9 is 3 times 3. Okay, so just to check it, I can make sure that I've got everything right. So 3 times 3 is 9, times 3 is 27, times 2 is 54, times 2 is 108, times 2 is 216. Looking for my buddies. I've got 2 2s and 2 3s. So those are what's able to come out. And I have to multiply 2 times 3. Under my radical, I have a 2 and a 3 also. So outside, 2 times 3 is 6. Under my radical, 2 times 3 is 6. So 6 times the square root of 6. And then the last one, 5 times the square root of 300. I have a 5 already, so I have to start there, okay? I leave my 5 as my whole number. Now I'm breaking down 300. It is even, so that'll be 2 times 150. 150 divided by 2 is 75. Well, hey, I've already broken down 75 a couple of problems before, so I know that that is going to be 3 times 5 times 5. All right, so I can check it. 5 times 5 is 25, times 3 is 75, times 2 is 150, times 2 is 300. Now look at my buddies. I've got 2 2s and 2 5s. Now, I already had the 5 that I started with. I'm pulling out a 2 and I'm pulling out a 5. So now I've got 3 numbers I'm going to have to multiply together. And then under my radical is just that 3. So 5 times 2 is 10, and 10 times 5 is 50 times the square root of 3. Any questions on those? Okay, having to remember back a lot, several sections ago, of thinking about prime factors, buddies, what I can pull out and what has to stay under the radical. Okay, standard scientific notation and standard form. It hasn't been that long ago since we went over this. It was just last week. So let's go through this again. Remember that when I have a positive exponent, I know I'm going to end up with a big number. That exponent tells me how many times I'm moving my decimal to the right. Since I'm making a big number, it's going to move to the right. So what I'm going to do is I'm going to go ahead and write my number kind of small at the top of my box up here, 6.519. And I know I'm having to multiply by 10 to the 8th. So that means I'm moving my decimal point 8 places to the right. I start where it is and go 1, 2, 3, but now I'm going to have to start filling in with placeholder zeros. So 3, 4, 5, 6, 7, 8. So each place I've got an empty, I fill in with a 0. So I have 6, 5, 1, 9, 0, 0, 0, 0, 0. I want to write my number all together first, and then I'm going to start from the left-hand side. I'm sorry, from the right-hand side and move to the left, count 3 to put commas. 1, 2, 3, comma, 1, 2, 3, comma. So I end up with 651,900,000. All right, 3.47 times 10 to the 9th power means I'm going to move 9 places to the right. So again, I'm starting with 3.47. I need to move 9 places to the right. I start with where my decimal is and go 1, 2, 3, 4, 5, 6, 7, 8, 9. All those places I have to backfill with zeros. So I end up with 347, 0, 0, 0, 0, 0, 0, 0. Make sure I've got all my zeros. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Start at the right-hand side, moving to the left, count 3 and put a comma. 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. 3,470,000,000 is your answer. Now, 8.4 times 10 to the negative 6th power. When I'm multiplying by a negative exponent, I move my decimal to the left. So I'm going to have to move my decimal to the left 6 places. So since I'm moving my decimal to the left, I'm going to start with my number over here, 8.4, and I'm going to move it to the left 6 places. 1, 2, 3, 4, 5, 6. Again, that's where my decimal goes now, and I fill in with zeros. So I'm going to have point, and I've got 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5, 8, 4. 3 times 10 to the negative 7th power. Again, I'm going to have to move to the left 7 places. When I have 3, my decimal is after it. So now I've got to move 7 places to the left. 1, 2, 3, 4, 5, 6, 7. My new decimal is there. Fill in with zeros. So I've got 1, 2, 3, 4, 5, 6 zeros and then a 3. So decimal 1, 2, 3, 4, 5, 6 zeros and a 3. Any questions on those? All right, now I want you to do the standard form to scientific notation. Now let's review our rules real quick. When we look at our scientific notation, remember this number here, what's in the front of the times 10 to the power? Remember, this is called our mantissa. And our mantissa is a number that is greater than, go away. There we go. Okay, so our mantissa is a number that is greater than or equal to 1, but less than 10. So it has to be between 1 and 10. It can be 1, but it cannot be 10, okay? So remember, we want to make sure our decimal place comes after the first non-zero digit. So we'll do the first one together, and then I'm going to have you do the rest of them on your own. So here, my first non-zero digit is 4. So I know my decimal will go between the 4 and the 8. Okay, so I know I'm going to have 4.85 is going to be my mantissa. It's going to include all of my non-zero digits. Okay, so it becomes 4.85. 4.85 is greater than 1, but less than 10. But also now what I've got to do is I've got to look at, in standard form, my decimal is at the very end. So now I'm looking to see how many places am I going to have to move that decimal to get it between the 8 and the 4. So I'm moving it 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So I know I'm going to have 4.85 times 10 to the 9th power. Okay. Let's go ahead and do this one right here. That's going to be our small number. I'm starting out with a tiny, or I guess a tiny, tiny number with a whole bunch of zeros after my decimal. I know that my first non-zero digit is a 7, so I'm needing to move my decimal to where it's after that 7. But now I'm having to move my decimal to the right to get there. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. So I had to move it to the right 10 places. So my mantissa is 7 times 10 to the negative 10th power. I want you to go ahead and do the second one and the fourth one. Change 27,600,000,000,000 to scientific notation, and I'm not even going to attempt to say that little bitty number with the decimal. All right, so the first one, I'm going to look at my non-zero digits. And I'm going to look to see where I would put my decimal to make it greater than 1, but less than 10. So I know that it's going to go between the 2 and the 7. To get my decimal moved from the very end of my number to between the 2 and 7, I need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places to the left. So I have 2.76 times 10 to the 10th power. So notice that one is a positive 10 because when it's in standard form, it's a large number. The one after that, that's 7 times 10 to the negative 10th, it's a negative 10 because we're representing a tiny number. All right, and then the last one, my non-zero numbers are 8, 1, 2. So I would put a decimal between the 8 and the 1 to make that a number between 1 and 10. My decimal starts over here, so I need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places to the right. And so I end up with 8.12 times 10 to the negative 10th place. Any questions on those? All righty. Well, it's 2:18, so we're not going to start another section. We're going to go ahead and just be done for the day. Let's go ahead and review our homework, what we've got. So go back to page 103. Convert percents to decimals and decimals to percents, right-hand column of activities 2 and 3. On page 104, activities 5 on the right-hand column, activity 6, those 3 proportions. And then on lesson 48, page 105, numbers 2 through 5, 8, and 11. We numbered those 2, 3, 4, 5, 8, and 11. Doing percents of numbers. Remember our formula of percent times whole equals part. Plug in what you know, solve for what you don't know. Any questions before we go? All righty. Well, if y'all have questions as you're doing your homework, be sure to let me know and I'll be happy to help you out. And if not, then I will see you guys on Thursday. Okay? All right. Y'all have a good week.
Bye.
Bye-bye. Alexis, let me know if you have any trouble with your catching up.